Okay, guys, so we are going to work this bridge and find out all of the forces and the stress or the tension or the compression in each of the beams. In order to do this, we have to work out the reaction forces in A and C as well as the angles. So the first thing that I'm going to be doing right now is going to be to find out the forces. So we're going to have three rules. The sum of forces in X has to be equal to 0. And there is actually only one force in this case on X. Remember that the pin support has a reaction in Y and a reaction in X, and the roller support only has a reaction force in the case of one axis, and in this case was for Y. So the only force that I have for X is the reaction force in X. And because all of them have to be equal to 0, the reaction force in X is actually going to be equal to 0. Okay? So the next thing to do is do all of the forces in Y as well as the moments. So I already know that I don't know two forces in Y. So I'm going to go ahead and start with the moments. We know that all of the moments have to be equal to 0. And I'm going to make the rotation with respect to A. So I am going to say that the moment in A is essentially going to be 0. So which are the moments that I'm going to consider? I'm going to have the moment that is going to be, all of them are going to be equal to 0, but I'm going to have negative and positive moments. There is no moment right here. So the only moments are going to be the force for 500 pounds at D and the one for C. D makes it rotate clockwise, so it's going to be negative, and C has a reaction going up, so it's going to make it rotate counterclockwise. So that's when it's going to be, I'm going to write here, this is positive, this is negative. So the moment in C is positive minus the moment that is caused by D is negative, and these have to be equal to 0. So doing a little algebra, I'm going to have moment at C equals the moment at D. The moment in C is going to be the force, or actually the reaction force in C, Y, multiplied by the distance from here, A, all the way to point C. That happens to be 10 feet. And this has to be equal to force at D, which is 500, and the distance being 3. Okay, so what this is 1500. So this means that the reaction force in C for Y equals 1500 divided by 10 equals 150 pounds. So all of my units I already know that are going to be pounds and feet, so I'm not going to be worrying about putting them inside of all of the equations. So now I have my reaction force in CY. The one that I'm missing now is the reaction force for in A for Y, because we already established that the reaction force on X was going to be 0. Okay, so I will write down my sum of forces in Y. And which ones are going to be positive? I know positive are going to be the reaction force for the supports, so A and C, and the only negative force is going to be the force in D. So basically, I will say the reaction force in A plus the reaction force in Y minus the force applied at D. All of this has to be equal to 0. We already have some values, so the reaction force in A is the one that I'm actually looking for. So I'm going to say this is going to be equal to the force in D, which is the vertical force coming down this way, minus the reaction force in C. So that force in D is 500 minus the reaction force, which we just found, 150. And this is equal to 350. count. So now I have all of my forces. Then I'm going to try and find the angles for all of my, the angles that all of the bridge has. So the next thing to do is find the angle. So I'm going to, these are essentially two angles, two triangles, where I need to find this angle here and this other angle, as well as the angles that we can see in the bottom. So I'm going to kind of draw the triangles. This is the triangle on the left side. I can see that this is 3 and this is 4. And I'm looking for this and that angle. This is a straight angle. The easiest way to do this is always with the tangent. So the angle is going to be tangent to the -1 of the opposite divided by the adjacent. So this is actually 4 divided by 3. This is tangent to the -1 of 1.33. And this happens to be 53.1 degrees. So this is 53.1 degrees. The one on the top here then is going to be the difference between the 53-degree angle plus the 90-degree angle, and to get to 180. That means this angle here is 36.86 degrees. So now I have the left side of my angles. On the right side, we have another triangle, and this triangle, I'm going to draw again. This is 4, this is 7, and I want to know this angle as well as that one. This is a right triangle. So in order to find the one on this side, I'm going to do that the angle equals tangent to the -1 of the opposite, which in this case now is going to be 4, divided by the adjacent, which is 7. And then I have 4 divided by 7. So this is tangent to the -1 of 0.57. Now I'm doing all of this step by step to make sure that you're working in your calculator and that you are actually getting the same numbers as I am. So the angle is going to be 29.7. So we can call this theta, 21.7, and I'm going to call that one phi. So phi is actually going to be 180 degrees minus 90 degrees, which is this one, minus 29.7. So 180. So this one is going to be 60 degrees. Okay, so 60 degrees, 29.7 and 90, that makes sense. That brings us to a total of 180 degrees. So once I have all of my angles, I can go back to my original figure and can fill out the values for the angles. So I can see that the one on A is 53.1. The angle on B is 36.8. The one on the second triangle for B is 60. And the one angle that we have on C is going to be 29.7. That way we have finished all of the external forces and all of the angles in our bridge or our truss. And the next thing will be to find out each action and reaction for each of the beams to see what is under tension and what is under compression. That will be the next step.